Listening to the DROIDS podcast. I'm Diana Wolf Torres, founder of DROIDS. At NVIDIA GTC, my associate editor, Alexander Wolf Torres, caught up with Aadeel Akhtar of PSYONIC. PSYONIC is one of those companies where prosthetics and robotics start to blur. The same hand used by humans is now being used to train robots. Here's that conversation.
I'm Dr. Aadeel Akhtar, and I'm the CEO and founder of PSYONIC. I'm here with DiMassi, who is our creative marketing manager, and we build bionic limbs for both humans and robots. So we're here at GTC, and we're showing off our new demo that we've got. And so one of the things that makes us unique at PSYONIC is that it's the same bionic hand that we build for humans that goes on robots. And so we can take data from our human users who have figured out how to do everything and then translate that over to the robotic side. And so Dale here, so he's wearing the prosthetic hand, and so when he moves it, you can actually see in real time on Isaac Lab that the hand is responding, and we can collect all that data. And then if he holds that cup of water, for example, you can actually see that it can track the touch sensors on there too, so he can modulate however much force he's using, and then we can use that to train the robots to do the exact same thing. So the same hand that goes on humans goes on robots.
So can you tell me about the advantages of using a more humanoid gripper like this compared to a conventional robotic manipulator?
Yeah, Dale, would you like to take that one?
Yeah, so more dexterity means you can take on more complex tasks. You can also reposition tools in the hand. Another thing is like having multiple fingers, having a little bit of compliance in the fingers and the silicone texture to it allows us to get a little bit better of a grip. And so when we're actually doing the work within the hand, you don't have to worry about the object that you're manipulating slipping out. This is going to help not just grab things more easily, but maintain that grip without whatever it is you're trying to do with it.
One of the big issues with prosthetics is the fitment, making sure it's comfortable, and the fact that in essence, everyone who needs a prosthetic is unique. So what's been your approach for the prosthetic side of things and making sure it fits?
Yeah, and so we have an interesting approach that we're taking on that in particular, in the sense that where we're heading with this technology is seamless integration between human bodies and robots, right? So the way that our natural hands are attached to our bodies is through our bones, our muscles, and our nerves. And so we're developing titanium implants and microwire electrodes that we can actually implant inside your nerves, and then they talk through the titanium implant that goes into your bones, and then we can attach the hand directly to your bones, your muscles, and your nerves. And that way, it's a much more natural interface, and it'll unlock a dexterity that we haven't really been able to see on that side. So there's an app for our hand, there's an app for everything these days.
There
right?
is indeed an app for everything.
And so I'm going to see if I can connect to it, and once I'm connected, this hand that I've been controlling this whole time with these buttons, you'll be able to control yourself.
Oh,
and so
wow.
if you put your hand in front of the camera,
like this?
just like that, and then bend your fingers.
Very impressive.
Yeah.
That it can invert even when partially occluded. That's very cool.
Yeah, and so that level of control where you can control each individual finger like that, that's what we want to unlock with the nerve implants and the muscle implants that we're developing.
Yeah, that was effectively, that would be the second question, is control. So, yeah, you got that covered. So you mentioned about, like, in essence, soft robotics and compliance. Can you tell me a bit more about how that's integrated into the system?
Yeah, so one is actually physically, so the fingers themselves, they have a semi-rigid thick bone that has a flexible portion in it, so that allows us to maintain rigidity in some areas and have a little bit of flex in others. And also the fingers are able to be laterally compliant, which most of the robotics hands can't do. So that's part of it. That's where it's built in physically. And then we've also built in mechanically into it some compliance. And what that does is, say I grab an object at like an odd angle or something, the hand is going to conform to it naturally. The same way our hand naturally does. We don't think about how we wrap our fingers around it. It just does that naturally,
yeah.
right? And so this hand is designed to be able to do the same thing. So it's really useful, like not just, again, just for grasping objects, but in the actual manipulation of objects, maintaining that grasp, maintaining it through different types of work makes a big difference. Having fingers that will kind of conform to things and like adjust with it.
On the physical design side, I noticed that is the material like carbon fiber? Yeah, and I presume that was done for weight reduction. So can you tell me a bit more about not only the considerations with carbon fiber, but how weight has been considered for the actual, I suppose, actuators themselves?
Yeah, so everything is located in the hand itself, just like this. So we can put this on a human, we can put it on a humanoid, a robot arm, a robot dog, like we've done all of those incarnations, right? And so the hand itself, it weighs lighter than an average human hand, so it's about 480 to 490 grams. An average human hand is around 400 or 520 grams, so it's lighter. So we wanted to be able to optimize that weight so it doesn't feel as heavy, especially when it's leveraged on a socket like that.
Yeah.
When it's connected to your bones eventually, then that'll make it feel even lighter than it is now.
What are you hoping to achieve next? You mentioned about in essence, integrating it into the bones, so.
Yep. Yeah, so on the clinical side, it's the implant, so we can really unlock dexterity, and then when you touch the fingers, so right now Aadeel will feel a vibration when we touch the fingers on his hand. When we do the nerve implants, it'll feel like a stimulation directly on the nerve, so it can feel like the missing hand. But then on the robotic side, we want to start training the AI models from the data that we're collecting so that we can have the robots do the same thing. So hopefully that's what we're going to be seeing soon, is just robots trained from human user data.